So, hello my dear students, I welcome you to NEET World. So, in this session, we will be discussing about bridge course only. So, this is completely regarding types of chemical reaction. Let us look into the some basics of how the chemical reactions are taking place. So, and what are the things involved in this chemical reaction during the process. Okay. So, all these basics we will be looking today. Okay. So, in the last class we have discussed about what IUPAC nomenclature of organic compounds, right. So, there are few more things to be discussed from the yesterday's topic. So, let us look into it first, then let us discuss about this basic chemical reactions part. Okay. Now, let us understand this. Okay. Here I will be starting from very basic here. Yes. So, while writing IUPAC nomenclature, what we need to follow? So, we need to follow basic structure given by the IUPAC standards, right. So, we need to write the word root first by counting number of carbon atoms in the longest like chain of that is what we are calling it as parent chain in the given compound. Okay. And we will be adding prefixes and suffixes. So, secondary prefix means the substituents, like if any methyl group or alkyl groups are attached. So, we are saying it as secondary prefix. If the compound is cyclic, okay, then we are writing it as cyclo as a primary prefix. Then root word given by number of carbons in the parent chain. Next suffix, primary suffix and secondary suffix. So, primary suffix is what? Whether it is saturated or unsaturated. If it is unsaturated, is it having double bond or single bond, like one bond, two bonds, like that. So, we will be saying that. And the next secondary suffix. Secondary suffix means principal functional group. For example, if the given compound, for example here you can see, so with this one example we can revise yesterday's class. See, we have something like this, right. So, how can we name it? So, here how many carbons are there? 1, 2, 3, 4 carbons are there. So, our root word is what? Bute. Okay, bute. And you know, here we have, let us put one methyl group over here. So, at the third position we have methyl group now. So, that will becomes prefix. Okay. So, what is the position of that methyl group? 3. So, 3 methyl bute. Okay, bute, and up to here it is done. Secondary suffix is there, primary suffix is there. So, secondary suffix is something like principal functional group. Here hydroxy group is secondary suffix, suffix. Okay. So, what is our primary suffix? It is double bond, ene, right. So, 3 methyl bute, 1 ene, all. Bute, this here on the first position we have an ene, so 1 ene all. So, this is how you need to write the naming. Okay. So, then next we will be looking into the IUPAC naming of this organic aromatic compounds. So, that is what we will be looking here. Okay. So, who is this? Did you know? Yeah. So, first listen to the class, then you can decide whether to listen or not. Okay. So, nomenclature of organic compounds in substituted benzene. So, here we have, so this is the unsaturated compound, right. So, whenever we have pi bonds like this, we can say it is unsaturated hydrocarbon. Okay. Now, it is a see, it is a 6-member cyclic ring with 3 pi bonds which are in conjugative position, that is what alternative position, and we are calling it as benzene. Okay. What is this? Benzene. Okay. So, this benzene, if we have any substituents, look here, for naming of substituted benzene compounds, the prefix used for the substituent is prefix to the word benzene. So, this is the benzene now. So, if we add any alkyl group here, for example, here I am writing CH3 group. Okay. CH3 means methyl now. So, whenever we have methyl group on benzene ring, so the substituent is written as prefix and the benzene as suffix. So, we should write it as methyl benzene. Okay. So, if this methyl group is substituted by any other groups like OMe, so we should write it as C. Here instead of having methyl, if we have methoxy group, OCH3. So, what we should write? Methoxybenzene. Okay. So, what is the IUPAC name of this compound? Methoxybenzene. Okay. Then next here we have amine group. For example, if NH2 group is there on the benzene ring, NH2 group is there on the benzene ring. So we should call it as aminobenzene. See, aminobenzene. Okay. Similarly, if we have nitro group, we should call it as nitrobenzene. And if we have bromine, so bromobenzene. So this is how we need to write the IUPAC name for the given organic compounds. Okay. Then next, we will be having few more things to be discussed here. See, what I told you, if there is methyl group here, so what we are calling it as methyl benzene, right? Methyl benzene. Okay. So now this is the IUPAC nomenclature. What is this? This is the IUPAC nomenclature. Now instead of having this IUPAC, what is its common name? So common name is called, whenever on benzene ring, if methyl group is there, so we can call it as toluene. So what is that? So toluene. So here I am writing toluene. Okay. So now if instead of having CH3 group, if we have OCH3 group, for example this is the benzene ring, on this we have OCH3 group. Okay. So what we can write it as? Methoxy. So OCH3, anything like alkyl group is there, like methyl group is there, along with one oxygen. Okay. So we should call it as alkoxy. What is that? Alkoxy. Here we have methyl with oxygen, so methoxy. If it is ethyl and oxygen, ethoxy, like that. Okay. So we are calling it as methoxy. So methoxy benzene, right? So methoxy benzene. And after this, you know, there is a common name for this, general name for this is anisole. What is that? Anisole. Okay, you can write it like this. Okay. So the next, on benzene ring, if we have aniline group, see on benzene ring if we have NH2 group, so let us write NH2 group is there like this. So we should call it as aminobenzene, which is IUPAC nomenclature we are saying, and the common name for that is aniline. What is this? Aniline. Okay. So like this. And if on benzene ring, if we have OH group, for example, here we have like this. So what is the name of this? So the name of this particular compound is phenol. What is that? Phenol. Like this. Hope it is clear. You can take the list of these compounds which are very, very useful. The common names are very, very important for these topics which we have discussed here. Okay. The next, so we will discuss few more things. So before that, yes, yesterday we have solved this question of priority order. So what is the priority order? We discussed carboxylic acid is more priority whenever there are multiple functional groups in the given organic compound. So we have to name the compound according to its priority order. For example, here I am writing a compound like this, and here we have something like OH group, and here we have something like COOH group, right? So now on the same compound we have multiple functional groups. One is alcohol, another one is carboxylic acid group. So how do we write the name of this compound? How do we write this? Okay. So based on the priority order. So how can we give the priority order? First of all, carboxylic acid is given more priority. Okay. Then next sulfonic acid, like that. So we have order. So this is a question based on the order of the priority of the functional groups, right? So first carboxylic acid, then next sulfonic acid. See, carboxylic acid, sulfonic acid, next CN, cyanide, okay, then next aldehyde, and list is alcohol in the given list. So option 1 is correct, we discussed in the yesterday's class also. Now since this is priority functional group, so you have to take this as a principal functional group, and these the other functional groups as a prefix you have to mention. So it means how many carbons are there here in the parent chain? So 1, 2, 3, 4, 5, right? So what is the name of this compound? On third position we have hydroxy. So 3 hydroxy. So 5 carbons means pentane. So is there any double bond here? No. So we can say pentane. Okay, pentane, like this. Now here you should remove this E and you have to write this oic acid as a suffix. Pentane oic acid. This is the name of the compound. Hope it is clear how we are writing the name of the organic compounds, right? Then next, here we have, so tell me, so this is the aromatic compound. So IUPAC naming for aromatic compounds we will be discussing now. So tell me, how can we write IUPAC nomenclature for this kind of compounds? So name of the following compounds we should give. See, here we have phenol group, NH2 group and methyl group. So how can we write the name of that compound? So first of all, this is benzene ring, right? Yes. So on benzene ring, if we have only amine, NH2 group, what we can say? Aniline. If it is not there, we should call it as aniline. If these are not there, only CH3 there means toluene. If these are not there, only OH is there means phenol we should call. But when we have all these groups, so you just follow the priority order. So as per the priority, so tell me which is more priority one. Hydroxy group is more prior now. So we can call it as phenol. Okay, so I can say it is derivative of phenol. So this is phenol, and here we have CH3 group, and here we have amine group. So I am writing it as 1, 2, 3 because A comes first when we compare with this M. So amine means A, methyl means M. So in alphabetical order, which comes first? A comes first now. So that's why I am coming towards this side while numbering. Okay, 3, 4, 5, 6. Okay, so what is the name of that compound now? So it will be 3 amino. Okay, next 5 methyl phenol. Yes, so 3 amino, 5 methyl phenol. So this is how you should write the name. Hope it is clear. Then next we will be moving further. Yes, so can you give the name for this compound? See, here we have fluorine group, and here we have nitro group, and here we have ethyl group on benzene ring. So how can we write? So all these are substituents only now? Yes, substituents. So the suffix is benzene. Now this becomes what? Prefixes. So while writing the prefixes, how can we follow them? So first of all, number them. So while giving the numbering to this, follow least locant rule. So it means the substituent should get minimum number. Total sum should be minimum. So how can we write that? So see, if I start numbering from here, 1, 2, 3, 4, 5, 6. Like this we will be writing now. So now, see, what are the numbers we have given for the substituents? 1 fluoro, yes 1, and 2 nitro, it means 2, and here we have 4 ethyl, so 4. So total sum is 7. If we give like this, this will be the sum. So if I start numbering from here, so 1, 2, 3, so it means it is 3, it is 4. So 1 plus 3, 4 plus 4, 8. So which is smaller number? 7 is smaller number now. So previously whatever the number we have mentioned, that is correct only. So it means we need to follow like 1 fluoro like that, and 2 nitro and 4 ethyl. These are the groups. Now here ethyl means E comes here in the alphabetical order, here fluoro means F, and nitro means N. So now tell me what is the alphabetical order for them. So E comes first now, so this should be written first. What is its number? 4. So 4 ethyl, yes. After that, after this we will be having fluoro. So what is the number of that fluoro? 1. So 1 fluoro, then next here we have 2 nitro, so 2 nitro, yes 2 nitro benzene. So this is first option is correct for this question. Hope it is clear. Now let us move further. See, I just wanted to know you, who is this? Did you know? I don't know. You are started commenting before the start of the class, and you are not at all listening to the class, I think so. You are completely in the chat box itself. Yes. So we don't require this kind of things. So just listen to the class. Yes. The next what we have here. So here the next question here is suffix used for ketone. So what is the suffix we will be using for ketone? Yes. So we just now we have seen the priority order, right? So in that we have different functional groups, so that we will be following priority order. So now how can we give suffix for this ketone as a principal functional group? When ketone is a principal functional group, so we have to use it as, we have to mention it as suffix. So what is the suffix for ketone? It is -one, right? So what about alcohol? It is ol. Alcohol will be ol. Suffix is ol and prefix is hydroxy. Okay, and for ketone the suffix is on and prefix is what? Keto group. We are saying keto or like oxo, right? Keto or oxo, depending upon the condition we have to specify that. Okay, then next here what about Al? So this is for aldehydes. So suffix for aldehydes is Al, butanol, methanol, like that we will be giving, right? And oic acid for what? Carboxylic acids. So oic acid will be given for suffix oic acid. Oic acid is given for what? For carboxylic acid. For ketones, so on is the correct one. Hope it is clear. Next, what is the IUPAC name of this organic compound? See, CH3, CH2, CH2, COOH. It means how many carbons are there? 1, 2, 3, 4, 5. So 5 carbons are there. So it means pent, right? So after writing pent, so what we can say? Oic acid, pentanoic acid. So we have option 2 as pentanoic acid. Hope it is clear how we are solving this kind of questions, right? Very basic. See, we already discussed that the course is completely bridge course where I will be covering very basic things first. Okay, before going to the real classes, I will be giving you only the basic part that will be very important for all your preparation. Okay, see, in this discussion also I will be including PYQs, because from the basics only you can solve the PYQs major, right? See, we have also discussed about isomerism. So tell me, what is the correct option for this question? Yes, see, all dear viewers, I mean all my students who are watching, so just please click on the like button so that it will be really boost us. Yes, yeah, now tell me, so what is the name of these two compounds here? Just look into this. So how many carbons are there? 1, 2, 3, 4, 5. Okay, at third position we have methyl group, and here 1, 2, 3, 4, 5. At second position we have methyl group, but parent chain having same number of carbons. So what we can say, the alkyl group position is different in first case and second case. So how do they differ? They differ in the position of the substituent. So we can say these are positional isomers. What they are isomers? They are positional isomer, because they are differ in the position of the substituent, therefore they are positional isomers. Hope it is clear. Then next, what we have here? So what we have here? So here we have how many carbons in this? So 1, 2, 3, 4, 5. Okay, here 1, 2, 3, 4, 5. So both of the chains, both of the compounds are having same number of carbons, right? But here we have triple bond and here we have double bonds, which are 2 times, right? So it means chemical formula is same. Okay, both are having same chemical formula, but they differ in the functional group. Here we have alkyne as a functional group. Here it is alkene, triple bond here, double bond here. It means they differ in what? The functional group they have. It means what we can understand, they are functional group isomers. Hope it is clear, this one also, right? Then let's move further. Yes, here, yeah, let us understand now, that is about basic organic naming and understanding about the naming of the compounds using IUPAC rules for organic compounds. Now let us understand how the organic reactions are taking place, and let us look into the fundamental concepts here. So we know during the chemical reactions we have something called reactants here. So these reactants will be converting into form products, right? Products. So this is what the conversion takes place, right? Now how this conversion takes place? So what are the reactants here? So what happens here? See, remember, to this reactant side we have 2 parts. One is called substrate, and the other is called reagent. So these are the 2 things we have, right? Okay, so now what happens is, this reagent, we can also call it as attacking reagent. It means this reagent will attack onto this substrate, okay, and will be giving us products. Okay, what it will be give us? It will give us these products. Okay, so reactant side we have substrate and reagent. This reagent will attack onto this substrate and finally gives us product. Okay, so during this conversion, it means from when reactant is attacking on the substrate, Okay, so sometimes during this conversion we will be having something called intermediate. So what is that? Intermediate, or we can say in some reaction we will be studying about transition state. Okay, so we will be seeing something like intermediate or transition state during the reaction, and finally it gives us the product. That is what the final product I have mentioned here. Hope it is clear how the basic structure is going on. Now look here, so this reagent again depends on two types. So if the substrate is electron deficient, generally if the substrate is electron deficient, I am saying substrate is electron deficient. Okay, so if it is electron deficient, our reagent will be generally, if it is deficient, this will be electron rich. Okay, so since it is electron rich, so this electron rich species will come and attack on this electron deficient site. So this is how chemical reactions are taking place. Now it can be in the reverse manner also. If our substrate is having electron rich, if this is electron rich, I am writing electron rich, then our reagent might be electron deficient. It is electron deficient. So this electron deficient species come and attacks on this electron rich and will be forming some intermediate and forming final product. Okay, hope it is clear. Now what we need to understand in the during the chemical reactions, you need to identify what is electron deficient site and what exactly where electron rich site is there. So just make a bond between those two sites, that will be our intermediate, which resulting to form the final product. Okay, so let us understand this. See, so attacking reagents you have seen two types, one is electron rich, another one is electron deficient. Now, so now what electron rich species, what is the name of this electron rich reagent? So this is called as nucleophiles. What is that? This electron rich species is called nucleophiles, and electron deficient species is called electrophiles. What is that? Electrophiles. Okay, hope it is clear what exactly electron rich and electron deficient. So I told you substrate plus reagent forms or reacts to form, combines to form intermediate or transition state, finally giving our product. Okay, so during this process reagents which we are using here, it is of two types, one is electron rich species and other one is electron deficient species. Okay, so the electron rich species is called a nucleophile and electron deficient species is called electrophile. Okay, so now we need to understand these two things, which is what is electron deficient, that is what electrophile, nucleophile. So now what we need to do during the reactions, just you need to identify electrophilic site and you have to identify nucleophilic site. So these nucleophile go and attack on this electrophilic site, that's it. This is what happens in the chemical reactions, organic chemical reaction. The main thing during the organic chemical reactions is what? You need to identify electron deficient site and the electron rich site and making a bond between them. Yes, this is the major criteria you have to do during the organic chemistry reactions. Hope it is clear what we need to do, right? So let us understand these reagents, electron rich and electron deficient species, that is what electrophile and nucleophile. Okay, so if you know anything about electrophiles and nucleophiles, just write in the comment box, I will be looking into it. Yes, anyone? Yes, anyone in the comment box? No one? Yes. So yeah. So I will be telling you what exactly electrophiles and nucleophiles, just follow the class. Yeah, give me a minute. Yes. So let us understand electrophiles. So electrophiles means these are electron deficient species. So electron deficient species means, so it can be the species which are having deficiency in electrons. It means, for example, we know species with octet electronic configuration, fully filled electrons in its orbital are more stable. If it is having deficiency, if it is having less number of electrons than the octet, it means lesser than the 8, then those species is considered to be electron deficient. Okay, so these electrophiles are again two types. One, it can be neutral, okay, it can be neutral, or it can be positively charged. Okay, it can be neutral and it can be positively charged. For example, neutral I am saying here, see BF3 I am writing. See, on boron, around the boron if you consider, so we have 3 fluorine atoms, right? So now boron, how many electrons are there here? 1, 2, 3, 4, 5, 6 electrons are there with one empty orbital, right? With one empty orbital. It means 6 electrons only there now. So in order to fulfill its octet, how many electrons are required? 8 electrons are required, but it is having 6 electrons only. So what we can say? It is electron deficient because 6 electrons only it has. It required pair of electrons to fulfill its octet. So can I say it is electron deficient? Yes, it is an electron deficient species, so that we can consider this is example for electrophile, which is neutral electrophile. So like this 13th group halides like BF3, AlCl3, BCl3, all this comes under the examples of electrophiles, neutral electrophiles. Now what about positively charged electrophiles? So here positively charged electrophiles means, for example, see around the carbon, if you put 4 bonds, 4 atoms are attached like this. See, 4 atoms are attached like this. Okay, so let me write here. Yes, 4 atoms are attached like this. So all the electrons are paired, like see around the carbon, see how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. Now see, because of difference in electronegativity of carbon and this chlorine, what happens? This chlorine will drag the bonded electrons towards itself, right? So that it will be giving us CH3 plus. See, electrons are taken by chlorine now, so it means carbon will be having positive charge because it is losing this pair of electrons. Okay, therefore it is generating CH3 plus and Cl minus. Okay, now this CH3 plus is having how many electrons? 6 electrons only now. See, here's 2, 2, 2. 6 electrons are there. These 2 electrons are taken by chlorine. Okay, so if it is 6 electrons, then it can be also considered as electron deficient. Okay, electron deficient. Hope it is clear. Now if it is electron deficient, yes, we can consider it as electrophile. What is that? Electrophile. Right? So and it is charged now, so we can say charged, positively charged electrophile. Hope it is clear. All carbocations are electrophiles, positively charged electrophiles we can write, right? Now let us discuss about nucleophiles. So what is this nucleophiles? These are electron rich species. Okay, it means they will be having either electrons equal to 8 or more than 8. Okay, so now look here, ammonia here I am writing. So now here we have two unpaired electrons, I mean 2 non-bonding electrons which are called lone pair electrons. Whenever we have this kind of set of non-bonding electrons or lone pair electrons, yes, so these lone pair electrons will attack on these electron deficient sites. See, here we have free set of electrons, right? So these electrons are what? We can call them as lone pair electrons or non-bonding electrons. So non-bonding electrons. So these electrons can attack on the electron deficient site. So that I can call this species as nucleophile because it is acting on electron deficient sites. Okay. So not only this, see even on water molecule if I write, see, it is also having pair of electrons like this. Yes, 2 set of electrons are there, 2 lone pairs are there. So it means this can also be act as nucleophile. And is there any charge on them? No charge, no. So we can call them as neutral nucleophiles. Okay. Similarly, see sometimes halogens will be having some negative charge, like then we are calling it as halide ions, right? So now here it is having negatively charged, right? So this can be negative charge is also donated to the electron deficient site, because it is having electron rich electron density is more now here, so that can be donated to the electron deficient site. Okay, so this species is now considered as nucleophile, and it is charge is there now, that negative charge is there now, so negatively charged nucleophiles you can call. Hope it is clear. If any non-bonding electrons are present or negative charge is present on that species, then we consider that as nucleophile. If electron deficiency is there in its neutral form or in its cationic form, then we can consider it as electrophile. Hope it is clear. Both are clear, right? Now during the reactions, what happens? During the reactions, what happens? See, there will be something like this. See, during the reactions what happens? There will be something like I told you now, substrate will be there and one reagent will be there. So between substrate and the reagent, reaction taking place, right? So now what happens here on substrate? Let us say electronegativity of this element X is more, therefore then this E, therefore what it will be doing? So it will be taking these bonded sigma bonded electrons towards itself now. Yes, like this it will be taking, right? Now it is creating something here. What it is creating? It is creating electron deficiency on this E, element E, by taking this sigma bonded electrons towards itself, this X atom. So now what happens? Since it is having electron deficiency, here we have a species called nucleophile, which is having electron density. Now what it will do? It will be electron deficient and this is electron rich. Yes, this electron rich species will come and attack on this electrophilic site here, right? Therefore this X minus goes out and we are getting a new compound, that is what new product is formed like this, X minus is going out. Okay, hope it is clear what's happening here, right? So what happening here? So this electron rich species coming and attacking on this electron deficient side and forming a product like ENU. Hope it is clear now? Yes. Yeah. Then next what we have here? Yeah. So fundamental reactions, I hope it is clear. Now I will be giving you one more example. See, I will be giving one generalized example here. So I am taking here CH3Cl I am taking. Okay. To these we will be adding OH minus. Okay. So OH minus, from where we will be getting something like a source base, let us say aqueous NaOH I am taking. Aqueous NaOH. Okay. So what we have here, Na plus Cl OH minus we have. Okay. So during this reaction, so let us understand how the reaction takes place. See, we know between carbon and chlorine, which is more electronegative? Yes, chlorine is more electronegative, right? Therefore this sigma bonded electron, see, this sigma bond electron containing 2 electrons is taken by chlorine only, right? Because of its electronegativity. Yes. So now when it is taking this bonded electrons towards itself, so what is the charge it is creating on this carbon? Yes, it is creating partial positive charge, because this is electronegative, it will be having partial negative charge. How these charges are arising here? Due to the polarization of this sigma bond, right? Now during this process it is having electron deficiency. See, electron deficiency is creating, therefore here we have OH minus ion, which is electron rich, having electron density, so that will come and attack on this carbon electrophilic site. Okay. So when it is coming and attack on this, see, at the same time this chloride ion is going out, therefore what is the resulting compound product we are getting? Yes, we are getting an alcohol product like this. So I can write CH3. See what it is attacking here? OH minus, na? Yes, CH3OH. Okay. And what is going out? Cl minus is going out now. Cl minus, and along with that here we have Na plus, no? So I am writing Na plus, Cl minus, Na plus. So we got product as methanol. Here we have methyl chloride, alkyl halide, and forming a alcohol, methanol is formed. So during this process what we have observed? So we have observed alkyl chlorides are converting into alcohols. Okay. So this is a chemical reaction only now. So we have prepared alcohols from the alkyl halides. Okay. So about this is a small example. You know, this reaction is called nucleophilic substitution reaction. We will be studying about that in the upcoming classes, but I hope you got some clarity what happens in the chemical reaction. See, now what is a substrate and what is a reagent here we have. So this will be the substrate is this one, and see what here we have, it is having electron deficient now. So I can say substrate is electron deficient site. If it is electron deficient, then our reagent, this attacking reagent must be electron rich, right? Then only the reaction takes place properly. So this is electron rich species. See, negative charge it is having. So I can call it as nucleophile. Yes. So this is what? Nucleophile. That's it. Okay. So this nucleophile, that is what attacking reagent is attacking on the electron deficient site. Hope it is clear. Right. Then next, let us move further. Yeah. So types of organic reactions. Now we have seen basic structure, how the reactions are taking place. Now let us understand types of organic reactions here. So organic reactions can be of different types. Here you can see it can be addition reaction, okay, or it can be substitution reaction, or it can be elimination reactions, or it can be rearrangement reactions, okay, it can be rearrangement reactions, and also it can be something called pericyclic reactions. We will be discussing this very little extent because it is not there in our like syllabus. Only Diels-Alder reaction we have. We will be discussing only what are the things which are there in our discussion, that will only be covered in these pericyclic reactions. Okay. So these are the types we have. Again, addition reactions, again it can be, we have what are the reactants we have, attacking reagents, what we have, electrophile and nucleophile. So this again addition reactions are like something like electrophilic addition reactions, okay, and we have also nucleophile, nucleophilic addition reactions. Similarly here also substitution, we have electrophile, so electrophilic substitution reaction, okay. Again nucleophile also we have nucleophilic substitution reaction. Yes. Again elimination reactions also further divided, E1, E2, E1, CB, like that. Okay. So we will be discussing all these things in the main sessions, okay, directly during the classes. Okay. Now I will be giving you some very basic types of chemical reactions. We will be looking into it. Okay. So what are those? Just look here. So types of organic reactions, we will be discussing about combustion reaction, next oxidation reaction, next addition and substitution reaction. Okay. So these are the things we are going to discuss in the class today. Okay. Now combustion reaction. So what happens in the combustion reaction? Let us take any hydrocarbon child. See, we know combustion of fuels, we will be seeing petrol, diesel, all these things. What happens? So the hydrocarbons will burn, undergoing combustion. It means when we treat with oxygen, will be resulting to form carbon dioxide, water, and like heat is released. That is what exothermic process now. Since it is releasing the heat during the combustion of fuel, the engines are working, the vehicles are working. So that is what happens here. See, carbon upon undergoing combustion with oxygen forming carbon dioxide, along with that heat is released. So this heat is used as a fuel, right? Okay. So this process is what? Combustion process, and we can also say this is also called as oxidation process. What is that? Oxidation process. Why I am saying oxidation process? See, methane with oxygen forming CO2 and H2O. Okay. Some heat and light, it means some heat and light is released during the burning of any fuel. What we will see? We will be seeing some light also now, heat also released now. So that is what the reaction takes place in the combustion process. Okay. So we can say combustion reactions are example of oxidation process. Okay. Yes. So can you write a balanced reaction for this equation which I have explained already in the beginning of the classes. So beginning of the class means what? At the like physical chemistry we have discussed some basic concepts of physical chemistry, that is what mole concept, those we discussed now. There I have explained combustion of hydrocarbons. Just balance this equation and tell me your answer in the comment box. What are the stoichiometries? So here I am writing 1, here I am writing x, and here I am writing CO2, Y moles of CO it is evolved, and you know Z moles of H2O is formed, and energy is also released. Okay, so during this process, what is this X, Y, Z? After balancing the equation, just write in the comment box, I will be looking into it. Okay, then next what we have here, okay, oxidation reactions. It means during the process, see, combustion reaction is also an example of oxidation only. See, this oxidation occurs in the presence of oxidizing agents. For example, here they mentioned alcohol. Okay, so oxidizing agent means what? It will oxidizes others, reduces itself. See, here we have alkaline KMnO4 or acidified K2Cr2O7. So alkaline KMnO4 means we can also say it as Bayer's reagent. So what is this Bayer's reagent? So I am writing KMnO4. Okay, so this is alkaline, it means basic medium. The reagent, oxidizing agent, this KMnO4 is taken in basic medium, that is what alkaline here. So these will be used to treat with this ethanol. Okay, so now what happens? Here we have alcohol. Now this is, so again this KMnO4, which is oxidizing agent, will oxidizes this alcohol to carboxylic acid. So what we will be getting? Carboxylic acid. It means wherever this oxygen is attached, this carbon it is attached now, so that will be converted into COOH group. So write CH3COOH. So this is what the final product. Okay, acetic acid is formed. So here see, OH group is attached to this carbon now. Yes, again this carbon attached to how many carbons directly? Only one carbon, right? So to this carbon it is surrounded by only one carbon. So I can say this is primary alcohol. Okay, if to the same carbon, for example here I am writing CH3, again one more CH3 here, and one hydrogen and one alcohol. See, to this carbon, this OH group attached carbon, two alkyl groups are present. So we can say it is secondary alcohol. Okay, so since it is secondary alcohol, whenever we are using some oxidizing agent like KMnO4, so what it will be doing? So it will be converting this OH, see this hydrogen is directly attached now, that also converts into OH. It means I can write CH3 here, okay, CH3 here, and already we have one OH. Okay, so this hydrogen also converts into OH. See, now on the same carbon we have two hydroxy group now, so just remove one water molecule so that you will get the final product, that is what? C double bond O, CH3, CH3. So ketone is formed. When we have secondary alcohol, that will be converted into ketones. When we have primary alcohol, that will be converted into carboxylic acids. Okay, so this is what you need to understand from the oxidizing agent, use of oxidizing agent in the organic chemical reactions. So it will be used for process of oxidation to get a desired product. Okay, so we will be having different types of oxidizing agents like KMnO4, K2Cr2O7 we have seen, then next PCC we will be having pyridinium chlorochromate, then next PDC we have something like this. Okay, so we have different types of oxidizing agents. Depending upon our requirement, we will be using that suitable oxidizing agent in the process. Okay, so that will be studying in the alcohols, phenols, ethers chapter. I will be explaining during that time. Okay, I hope you got some basic idea here. What oxidizing agent will do? It will oxidizes others and reduces itself. Okay, so now similar to this, we will be also having reducing agents. So what is the use of reducing agency? In order to convert alcohol to ketone, for this oxidation process, we have used oxidizing agent like KMnO4. Now I want to convert this ketone to the alcohol. It means reverse I wanted to go. So what I can use? So here I can use reducing agent. So reducing agent will, what it will do? It will reduces these compounds to respect to alcohol, ketones to respect to alcohols. So the suitable reducing agent here I can use NaBH4, I can use sodium borohydrate, okay, or lithium aluminium hydrate. These all are what? Reducing agents. Okay, so you have studied something about oxidizing agent, reducing agent, and how do they work in a basic level, right? Next, addition reactions. First one is combustion, next oxidation, next addition reaction. So simply you can just remember, see, we have a compound A, substrate A, to that we are adding something like B and forming a final product AB. Okay, so what we did, so we just added B to this A, so therefore we got AB. Okay, so this is a general way of understanding. Now I will be giving you the real example here. Okay, see, we have alkenes now. Let us say ethene we have, so it will be something like this. Ethene we have something like this. Okay, so to this I am adding hydrogen gas in metal, using some metal like nickel, palladium or platinum metal I am using. Okay, so under heating condition, like whenever we are using nickel, we require around 200 to 250 degrees Celsius. It is not required for palladium, platinum, but especially for nickel it is required. Okay, the process happens with nickel only at high temperatures. Okay, you can remember like that. So now what happens, this hydrogen, it means hydrogenation of this compound. This ethane is there na, hydrogenation of ethene using metal catalyst. Okay, so just remove this. See, we have two bonds now, one is sigma and one pi bond now. So just remove this pi bond, remove this one bond from here and add hydrogen here and here. See, this is what the conversion you have seen, observed here. See, these two hydrogens which I highlighted, H2 will be added to this CH2. So here I am adding hydrogen. So what is the difference you have seen? Initially we have only two hydrogens on each carbon and one pi bond and sigma bond. Here you have added these two new hydrogens to this. Yes, so you have removed nothing, you just added the atoms. You just added atoms, but you haven't removed any atoms or anything like that. Just you added atoms only. So addition reaction means you need to add something to the substrate. Reactions in which unsaturated hydrocarbons add hydrogen in presence of catalyst to form saturated hydrocarbon. These, whenever we have at least one pi bond, we can say unsaturated. So unsaturated. So converted into saturated compound. Hope it is clear what conversion is taking here. Okay, then next. Yes. So the next we will be discussing here few more things. Yeah, substitution reaction. So what do we mean by substitution? See, when we are playing a game, for example, we are playing kabaddi, you can assume. Okay, so if we want to substitute one player, see what we can do. If we want to replace one player, yes, so we will be taking him out of the court and we will be making other person to come inside, other player to come inside. So this is what the replacement, right? So that is what happens in the substitution reaction. So beginning I told you, using this methyl chloride. Yes, methyl chloride upon treating with this NaOH I told you. So here I just wanted to introduce this OH minus 2 onto this carbon and I wanted to remove this chlorine. So this is replacement only na. Yes, this is substitution only na. So we are replacing this chlorine with this OH minus. So that is what happens in the substitution reaction. So that finally what will we get? CH3OH plus Cl minus. So this is what the substitution reaction. Okay, so now if you look here, methane we have here. So from this we have 4 hydrogens and here we have chlorine. So what happens here? So during this process, okay, we will be using sunlight. So whenever we have alkanes, okay, here I mentioned methane. To this we are chlorinating. It means halogenation or chlorination, since we are using chlorine here. Okay, so we are chlorinating this methane. So what we need to do here, we need to remove one hydrogen and replace it with one chlorine atom, right? So chlorine atom. So that we got methyl chloride. So it means this is also substitution process only na. Yes. So this is what substitution reaction. Okay, and specifically if I want to talk about the mechanism, it is called as free radical substitution reaction mechanism. Okay, so just read the definition. The reaction in which one or more atoms or group of atoms of a substrate replaced by the same number of atoms or group of atoms of the reagent. Okay, generally given by saturated hydrocarbons. So this is what the example you can see. Okay, so this is simply called as, this example is simply called as nucleophilic substitution reaction, and this is called as free radical substitution reaction mechanism. Hope you got the difference what I am explaining here, right? The next, anything to be discussed here? Yes, let us discuss. Explain, like give me the answer. Chlorination of ethane here I have mentioned. In the previous slide, here what I told you, chlorination of methane. What is that process? Substitution reaction, right? So here also chlorination of ethane, it means you just take CH3, again CH3, to this you need to add chlorine, right? This is what chlorination. So this process happens in presence of heat or sunlight. Sunlight can be shown using H nu condition, okay? So now during this process what happens? So like either one of the hydrogen or more than one, depending upon the amount of chlorine we will be taking during the reaction, the substitution happens here. So if we take only limited amount, so what happens, the major product formed here will be like this. One of the hydrogen is replaced by the chlorine, so CH2, okay? So one hydrogen you remove from here and replace it with chlorine, so that we will be getting ethyl chloride. Ethyl chloride is our product. And what is our byproduct here? HCl, hydrogen from here which we replaced by chlorine, and another chlorine from here forming HCl. So these are the things formed here. So our substrate is converted into this form. So what is the change we are observing? What is the conversion? One hydrogen is replaced by chlorine. So can we say substituted? Yes, hydrogen is substituted by chlorine. So we can call it as substitution reaction. So where do we have option? Option number 4, which is substitution reaction. That is the correct one. Hope it is clear what's happening here, right? Next, which are the following statements is or correct? Okay, so tell me which are the following is or incorrect. Okay, they are asking about incorrect statements in the given 6 statements. Yes, tell me. So alkaline KMnO4, yes, we have discussed, it is a good oxidizing agent. Yes, this is correct statement. They are asking about incorrect one. See, KMnO4 is a reducing agent. No, KMnO4 is a oxidizing agent. See here, manganese in +7 oxidation state. What is the oxidation state of manganese in KMnO4? Potassium permanganate, it is +7. Okay, so now if it is in +7, it can be, it means this is a maximum oxidation state of manganese. Okay, it cannot undergo oxidation, it can undergo only reduction. When it is in any element in its maximum oxidation state, can undergo reduction only but not the oxidation. So that I can say this is oxidizing agent but not the reducing agent. They are asking about incorrect now. Yes, second statement is incorrect. Okay, they are asking multiple statements may also be chosen here, because statements they mentioned is or they are saying. Read all the statements. Combustion is also type of oxidation reaction. Yes, combustion is also type of oxidation only now. Like addition of oxygen is called oxidation to the carbon. It means combustion reaction of carbon if we say. So carbon plus oxygen gives CO2. This is what happens now. So addition of oxygen to the carbon is what? Oxidation. So it means this is also correct. Okay, correct. They are asking about incorrect statement. Addition reaction changes the saturated hydrocarbon into unsaturated hydrocarbon. Is it true? See, saturated means what? We have alkanes. Unsaturated means alkenes and alkynes. Okay, so now addition reactions, what happens to in the addition reactions, we will be adding some reagent to the substrate, some reagent to the hydrocarbon, so that it will be converted into saturated one. Unsaturated species converts into saturated, but they given in the reverse manner. Saturated is converting into unsaturated. This is not the thing. So this happens in the elimination reaction but not in the addition reactions. Okay, so I hope it is clear. So this is also incorrect one. Okay, next, chlorination of methane occurs in the presence of sunlight. Yes, chlorination just now we have seen now. Yes, free radical substitution reactions takes place in the presence of sunlight or heat, that is what, high temperatures. Okay, and this is correct statement. Fifth one is correct statement, but fourth one is incorrect statement. Okay, that you have to choose. And NaBH4 is a what? What I told you, NaBH4. While discussing about oxidizing agent, KMnO4 is oxidizing agent. Sodium borohydride, NaBH4, lithium aluminum hydride. So all these are reducing agents but not the oxidizing agents. So this is also incorrect. You have to choose this. So what are the options we need to choose? 2, 4, 6. These are the options you need to choose in order to answer this question correctly. Hope it is clear. The things are going very smoothly, right? If you have any confusions or anything to ask, you can write in the comment box now. Yes, I will be waiting for your queries here. Yes. So anything to be asked here? Yes, nothing, right? So I hope everything is going well, right? If you have anything to ask, any difficulties you are facing, then feel free to ask in the comment box. I will be really looking into your comments and I will be addressing them very patiently. Okay? So thank you for watching. Stay connected with us. Thank you. ఎవర్రా వీడు నాకు అర్థం